All right. Good afternoon. My name is Jason Berwin. I am the Vice President of Policy here at the Energy Storage Association. And I wanted to thank you for attending today's webinar titled NFPA Standard 855 and the International Fire Code. Just so folks are aware, today's webinar is being recorded and will be available on the ESA website at energystorage.org. Your participant lines are muted throughout the webinar. However, we do welcome your questions and comments, which can be submitted at any time via the chat box on the left side of your screen. And then following the webinar, you will receive a link to the recording and slides, as well as a brief survey regarding today's topic and topics for future ESA webinars. Your feedback will ensure that ESA continues to provide the highest value information to you and your company. All meetings and teleconferences of the Energy Storage Association are held in accordance with our antitrust guidelines, and so we ask that you abide by these guidelines during today's webinar. The full guidelines are available in the members-only area of the ESA website. And as many of you know, today's speaker is Chuck Foster, who's been a technical consultant to ESA on these issues associated with codes and standards. I'm really pleased to welcome him back to the webinar, so thank you, Chuck. Before I turn the microphone over to him, though, I'd like to just remind folks that registration for the 2018 Storage Studio Conference is now open. Produced in collaboration with the Electric Power Research Institute, the Studio Conference is designed to examine the steps necessary to successfully integrate an energy storage project and evaluate the ways companies are deploying storage to lower costs, reduce emissions, and establish a more resilient grid. The conference will be held in Charlotte, North Carolina on October 16th and 17th, 2018. For more information, please visit energystorage.org/studio. And then a quick note to our member companies, please be sure to update your contacts with ESA. Visit energystorage.org/members and let us know if you have any new employees, a change of address, or any updated information, because we would like to make sure that all members receive timely updates and information from ESA. All right, thank you. And without further ado, I will hand it over to Chuck to begin today's presentation. Chuck?
Good afternoon, everybody. Thank you, Jason. The topic this afternoon, as Jason said, is the exciting world of codes and standards with a focus on National Fire Protection Association Standard 855 and the International Fire Code. Codes and standards is not the most exciting place in the world by many measures, but it's a very important area. They can either support people's products and services, or they can impede it. And without going too much further into that, what I wanted to do was to just give a brief bit of background on NFPA 855, then move to the International Fire Code, same thing, a little bit of background, and then set it open for questions and answers. We had a list of questions that are carryover from our meeting in June, webinar in June. So I'll be using those, but I would invite you to submit your questions via the chat box that was referenced earlier. So the NFPA Standard 855, there's an existing Standard 855 that was published 3 or 4 years ago, I guess. And what the process that we're involved with right now is a first revision of that standard. The standard purports to establish safe installation requirements for electrical energy storage systems. And the current process got started in 2017. Actually, it was started in fall 2016, but the first actions that were available for the public were in October 2017 when public comments were filed. And based on those public comments, the NFPA committee, 855 committee, looked at each one of those comments and made a up or down determination on it, with the idea that comments that received the consensus approval of the committee, all the committee members, were then incorporated into the next draft, and comments that did not receive that consensus approval were not, of course. So after about 500 or 600, someplace between 500 and 600 comments were filed in October 2017, by May 2018, this year, the committee published its first draft report. We'll digress here just momentarily. That sounds rather clean. The first draft report published in May 2018. Many people may think that means that there's one single document you can go to, flip to it, read through it, make your comments, and be done with it. And unfortunately, it's just not set up that way. What the first draft report actually is the old standard with 500 or 600 proposed changes to it, and you have to try to integrate, flip between pages, and many of you, I think, were filed comments or participated in that activity and know how frustrating that was to not be able to simply turn to one consolidated document that had all the accepted changes incorporated. At any rate, enough of my griping there. After that first draft report was published in May, the public was again invited to file comments in July for a second round. And now that second draft report is expected the first week of October, here, just a week or so. Again, it's not going to be one single document. It won't be easy reading. I have to take the first draft report and then look at what proposals were accepted by the committee and see if that's how you'll determine what the current second draft report looks like. The codes and standards world is replete with acronyms. Here's a good one: NITMAN, Notice of Intent to Make a Motion. And that's a process unique to NFPA, which amounts to I'm going to call it an appeal, not to be confused with another appeal process, but if a commenter looks at the second draft report and they think that's just not right, I can't live with what that says, that commenter has the opportunity under this NITMAN process to file a NITMAN, a motion, and you can see there's about 5 weeks between the time the second draft report is published in October and when the NITMANs are due, 12/6/18. And we can expect final publication of the standard in the summer of 2019. So there is a separate appeal process that I left off our schedule, left off this slide here intentionally, but between the NITNAN and the expected final publication, there are essentially two appeal processes, the NITNAN and the appeal. I presume I could take questions now if anybody had them, or we can go on and you can verse if you have questions, you can add them later. I don't see any in the chat box yet. So now I've moved the slide over to something called the International Fire Code. And the Fire Code is published by the International Code Council. For anybody here that's an old-timer, the International Code Council, you may remember, is the amalgamation of the old Southern Building Code, Boca Code, and the California codes, West Coast codes. I can't remember what their acronym is at the moment. Anyway, the ICC, International Code Council, has been around now for 25 years, and they have a family of codes that includes the International Building Code, and International Property Maintenance Code, zoning codes, mechanical code, energy codes. I think they have about 25 or 30 codes in their family that they publish. One of the more prominent being the International Fire Code. And the International Fire Code is published on a 3-year publication cycle. The last published, the current version of the IFC was published in 2015. So if you go to the ICC bookstore, you'll see 2015 IFC for sale. So in January of this year, the IFC accepted proposals to changes to the 2015 document, and all of those changes were reviewed and put into a monograph that was available to the public in March of this year. Subsequently, and there was a 2-week hearing in April. ESA represented your interest there, and public comments. And so at the hearing in April, all of the proposals that were submitted, which were around 300, were considered, and some were accepted, some were rejected. Very similar process, structurally anyway, to the NFPA process. So they had a hearing, they accepted some of the proposals, they opened it back up for the public to comment in July, and now there's going to be a hearing in October that will cinch up the 2018 IFC, and it won't be dealt with again on a wholesale basis until 2021 because of the 3-year publication cycle. I should flip back just for a second to NFPA and note that it's not on a fixed publication cycle. In fact, it's I said earlier that we're expecting final publication in the summer of 2019. There's already substantive discussions about reopening, starting the process all over again almost immediately for standard 855 right after it gets published next year. And the rationale for that is that the technology is moving so quickly that to sit by for 3 or 4 years, as they did with the last publication, would just leave it less than what they like to see it. The batteries, chemistries are changing, and densities are changing, and controls are changing, etc. And at any rate, look to see NFPA come out. I would expect no later than 2020 they'll start looking at the process again. One of the questions that someone asked back in the summer, that was submitted back in the summer, was, well, if you have standard 855 and it deals with energy storage, and you have the International Fire Code, and Chapter 12 there deals with energy storage, why do we have two overlapping standards? Or one is a standard and one is a code, but why do we have two separate documents dealing with the same subject matter? And it's a great question. I'm not trying to be too smarty about it, but my first thought that comes to mind is that we live in an imperfect world. In a perfect world, it wouldn't make much sense to duplicate these efforts. But this is where we are. The ICC, International Code Council, publisher of the International Fire Code, is very there's some turf consciousness here. They're jealous of their success with the International Fire Code, which has been accepted in 43 states plus the District of Columbia. And in some ways, they could be viewed as a competitor with NFPA.
Great.
Was there a question here?
Chuck, I'm sorry. Were you finished with your presentation of the difference between NFPA and IFC and the processes for folks?
I think so.
Great. Okay. Well, maybe what we can do then is obviously start moving to the Q&A. That was intended for folks who are on the line as sort of a general overview background of the processes. Obviously, ESA has been holding these webinars on codes and standards issues previously, and part of the intention for today, based on member interest, was really to get a lot of Q&A in for this teleconference. Lots of folks who had questions that we didn't have time to get to on the previous webinar. And so if it's all right, please, again, in the left side of your screen, there's a chat box where you can start to give questions to Chuck and myself. But I'm going to start this off with some of the unanswered questions from our previous discussion. So Chuck, there's a lot of questions here. One of the questions is associated with well, first of all, there's a simple question. Is there a code number in the IFC code parallel to NFPA 855? Is there a specific reference number you can give folks?
Sure. It's just the date of publication. So the IFC International Fire Code 2015 is the current, most current IFC document, and as I said earlier, this year they will publish the 2018 version. Actually, it'll be probably spring of next year, I think, before they actually get it out the door. But the next published version, the numbers associated with it, Jason, will be 2018.
Great. And another note that's come in previously, the IFC code is accepted by 42 states and NFPA 855 has none. Why is 855 even necessary?
Right. Well, and adding some additional background to that, if one were to look at the players at the IFC, at the International Fire Code, you see that there's just a whopping overlap of participation between the two, so much to the extent that there's questions amongst both of those parties, 855 and IFC, as to whether or not they could work more in harmony. Where the idea would be that maybe the IFC would simply incorporate by reference standard 855. Adding some tension to that suggestion is this turf issue that I was talking about before. The ICC earns a lot of revenues, as does from the sale of the International Fire Code, and I think that they're not real interested in ceding that over to something of a competitor organization. And
right.
But Jason, it may actually lead to another related question. To the extent this said, why don't we just give up on 855? These codes and standards are not self-enforcing. So let's say that one of the picks on state, California, that publishes its own fire code, but it's based on the IFC. Let's suppose that at the end of this IFC code cycle, California will look at the IFC changes, and it will pick out what it likes from the IFC 2018, and will not pick out, not use what they don't like. So the point I'm trying to drive here is that the codes and standards have to be adopted by political jurisdictions. That would be state jurisdictions and home rule states, the local jurisdictions. And some of them have chosen 855. Some of them have chosen the IFC. There's not a much better answer I can give.
No, that's fine. All right, I'll start diving into some more details around specific items in them. We have a question here from the call. What is the expectation on the NFPA requirement on drive pipe sprinklers? So I assume with fire suppression in NFPA.
Okay. I'm not sure. During this last code comment period for NFPA, they received about 860, as I recall, proposals, of which there were a pretty fair amount of them had to do with fire suppression, which is a key item there. I'm not going to be able to answer too much specifically on the resolution there because it's not been published. I I would be happy to look into it, and could probably get back to whoever the questioner is
Sure
just
thing.
in a day or so. If that would
I
suffice.
appreciate that.
As I said, a lot of these, as I recall, dry type is approved. It references over to the NFPA sprinkler code, and I can't remember which one that is. The sprinkler standard. Somebody on the phone may be able to jog my memory here, but if we can take that
Sure.
one as an, and I'll look it up this afternoon when we get off and send back a public reply.
Thanks, Chuck. On the related note of fire suppression, another question from last time that didn't get answered. Can you provide clarification if one fire suppression system vent is adequate for a 53-foot container?
The most direct answer I can give you is I don't think so. I think it would, again, the NFPA standard 855 is going to does reference the NFPA sprinkler code, and that if the question was, will one sprinkler head suffice, my answer is no. I'm going to be hard pressed to, off the top of my head, give a straight answer. But again, I could put that in the queue for the same answer. I could find that one when I'm looking at the dry type sprinkler.
Sure thing. That's great. And I'm going to go back to the call, and this is probably helpful because I think that some of the folks who are on this call have been following this conversation more closely, have been on the previous webinars, but maybe this will be helpful for other folks for whom this is the first. Can you speak specifically to what's being considered, which could impact the various storage technologies in terms of acceptable system sizes, space constraints, suppression, and UL standards? Are they significant changes to what is currently in practice? I think this person is asking for a little bit more detail, just at a high-level summary of the main things that are changing that have drawn the interest of this industry. And so I imagine that has a bit to do with the spacing and the kilowatt-hour limits. Maybe you could just give
Sure.
folks a quick refresher on what's in play.
So, irrespective of whether you're talking about standard 855 or the IFC, there's essentially a 20 kilowatt threshold, 20 kilowatt hour threshold. So storage systems that are less than 20 kilowatt hours, this is not applicable. So 20 and above is where you start having some sizing and space constraints. 855 right now, before is, let me see if I get this right here, is 50 kilowatt hour individual storage system max, while the IFC is 250 maximum. And that's per array or cell. There is a 3-foot separation required, and the maximum rated energy per fire area is 600 kilowatt hours. So I'm not sure if that's, so it's 250 individual energy storage systems, 250 kilowatt hours, 3-foot separation, 600 kilowatt hours maximum rated. That's before, so if you meet those, if you don't have a density greater than 250 kilowatt hours, and you meet the 3-foot separation, and you don't have more than 600 kilowatt hours maximum rated energy, you don't have to do any large-scale fire testing. if you exceed those values, and let me back up for a second. The 600 kilowatt hours, we had asked to be raised up to 1,000 kilowatt hours, and part of our proposals, and the 855 committee didn't accept our proposal, so it might be something to keep in mind for next time. At any rate, if you don't meet those 250 kilowatt hour, 3-foot separation, 600 kilowatt hour maximum rated energy, then that bounces you. You either can't do it or you have to provide large-scale testing, large-scale fire testing. And I saw in here a moment ago somebody, Andre, and I can't even begin to say his last name, but he's a member of the 855 committee. His memory may actually, he referenced me to NFPA 13 on the sprinkler question, and I don't know if we could, Andre, would you be interested in adding any color to what I've just said there on the large-scale fire testing? We had asked for representative testing, and I believe that they approved that, but I'm not positive.
Andre, I've unmuted you if you'd like to respond to that.
Sure. So as Chuck mentioned, the significant differences are the 3-foot clearance around any array size up to 250 kWh and the maximum allowed quantity of 600 kWh in any fire area. If you want to exceed those numbers, or if you want to make the clearance smaller, you need to go through what's referred to as large-scale fire testing. There's still some debate of what large-scale fire testing actually means, but for reference purposes, everybody is pointing at UL 9540A as an alpha.
And I, oh yeah, go ahead, Chuck.
Well, I was just going to point out that 9540A is a test procedure. UL 9540 is the UL standard for electrical energy storage. And I've had a question in the past, what's the difference between 9540 and 855 and the IFC? One way that I've thought about it is that 9540 and the test procedure 9540A are product standards. So if you're going to have an energy storage system and you want the UL designation on that system, in fact, you probably almost always have to have it now, but that's what 9540 does. On the other hand, the IFC and 855 can be thought of as installation standards. They, in fact, reference 9540 on a number of times, each one of them does, but while one is a product standard, the IFC and 855 are installation standards. You were getting ready to say something.
Yeah, so there are a lot of questions on this count, so I'll try to take them one by one. And a couple of questions are on the relationship between UL 9540 and the standards, which you were just getting into. One of them is, what's the relationship between UL 9540 and the 3-foot minimum spacing? That is to say, if you're using UL 9540 certified batteries, do you still need that 3-foot spacing between the battery racks?
Yes.
Great.
The 3-foot spacing is part of the installation. So while the 9540 would 1973 and 1741, I think, are the two, the inverter and the charger UL standards.
Yep.
But it's for a system, and whereas the 3-foot requirement is an installation issue.
Great. Another question on a related note, which is, has there been any significant differences in the latest update to UL 9540A from June 15th?
No. It was updated in, I guess it was June. I can't remember. This summer, sometime. It wasn't updated. It was published, and they'd been working on 9540A for at least a couple of years.
Great.
The scuttlebutt that I've heard is that it was very difficult, as it was originally written. It was very difficult for manufacturers to pass, and that they took it back earlier this year and worked on some of those areas that were problematic. But since someone may correct me here, but I'm not aware of any updates since the summer publication.
Okay, great. Just moving forward on more associated with the large-scale fire test. Does that large-scale fire test that you mentioned require a destructive test of the maximum number of battery steerings in the system?
Well, I don't. This is going. I think Anjay hinted at this earlier. I don't think so. Is the best answer I can give. We wrote in comments that said, surely large-scale fire testing can't mean that if you're going to put in a 200 kilowatt-hour system, that you have to destroy you have to burn intentionally burn a 250 kilowatt-hour battery or system, and I think that it was generally conceded that was improbable, but I'm not aware of any final definitive answer. Maybe somebody else here is, but I'm not.
May I jump in, Chuck? This is Andre. Yeah. As presently written, there's the term representative. So, for example, if you have a megawatt hour in a 40-foot container, the idea is that you test one rack of batteries, so it's probably somewhere between 50 to 100 kWh, and you dedicate that one rack towards the burn test, and you verify that any significant fire event in that rack does not propagate to an adjacent rack based on your installation procedure. So if your installation procedure has a 3-inch clearance between racks, that's how you test it during large-scale fire testing. You don't need to populate the adjacent rack fully. You're able to verify whether it propagates or not with thermocouples. And as long as the thermocouple temperature doesn't exceed the ignition temperature established in step 1, which is cell level testing, it's a pass. There's also an additional condition of 97 degrees C over ambient temperature rise on the walls of the unit. So that's the secondary criteria for passing 9540A. Although for containers, outdoor containers, there's debate on whether it's necessary or not because you're outdoors.
Yeah,
Thank you,
Anjay, the two related questions. We had, ESA had filed comments specifically asking for the addition of that word representative or clarification on that. And so that was a helpful comment there. And secondly, on the rack spacing, just to make clear that I understood you, did the committee position is that 3 foot spacing is the default, and you can do this representative one array or burn, and the adjacent racks don't need to be populated. There was supposed to be a question hidden in there somewhere. Jay?
Yes. So the 3 foot is default. So if you're maintaining 3 feet, you do not need to do large-scale fire testing. But if you're going below 3 feet, that's when you need to do large-scale fire testing. And then the separation of while you're doing large-scale fire testing, you get to decide how close you want your system to be, whether you're doing side-by-side racks, whether you're doing 4-inch gaps between racks. So you control the burn based on your installation and the recommendations.
Okay, thank you.
Great.
That was helpful.
I'm going to just jump on a couple more of the questions that are in this theme. One question, which is for folks who are looking at is there a field evaluation equivalent for UL 9540A? That is, if creating an ESS for a site that is not an ESS product. Typically, a field evaluation is required if it does not meet UL 9540. So I think that's the basis. Yep.
I'm sorry. Go ahead, Jason.
Go ahead.
I was just going to say there's an equivalency provision. There was concern about specifying 9540 and it being proprietary, and so the administrative provisions contain provide for the opportunity to do an equivalent, to provide an equivalent surety as to the safety of the system that you don't have to use 9540, but for all practical purposes, I think you probably do, but maybe not. I mean, if somebody has a testing procedure, they could submit it to their AHJ, and if they can convince them that it provides the equivalent level of safety as 9540, then it should be acceptable.
All right. Moving on. So a lot of questions here associated with the spacing. Here's one question from the call. If I was to buy a standard ISO container, say 40 foot long, 8 foot, using 19-inch rack mount battery modules, rack 14 or so high, will that rack need to be 3 foot from the container wall, that is placed down the middle of the container?
I believe that for the containers, for the non-combustible containers, that they need 3 foot spacing in between racks, but that they don't need to be 3 feet. If you can give me a second, I'll try to look that up. But I'm pretty sure that they can bump them right up against the wall in the non-combustible container, but they have between racks. They need to maintain the 3 feet unless they go through large-scale testing and hazard mitigation analysis.
Right. And certainly that sounds like someone who's talking about a walk-in container. There's a related question here, which is, can you explain how non-walk-in cabinets that is not occupiable by a human are treated by NFPA and 855 and IFC 2018 with respect to the 3-foot separation requirements, and for that matter, with respect to the 600 kilowatt hour requirements? Our company has received conflicting explanations.
And so they were talking about a non-walk-in?
Correct.
I believe that the answer is the same, that they don't need to be 3 feet from the outside wall, but they need to be 3 feet between racks, unless they have performed full-scale or large-scale fire testing.
Got it. It sounds like someone has asked, I think, a very similar sounding question. Does the 250 kilowatt hour per battery set and 600 kilowatt hour energy storage system limits apply to only energy storage rooms, or does it include containerized solutions as well? I think you've just said that that for containers you can be up against that wall, but let me know if I've missed a nuance in that question.
Yeah, as I understood the question, they can, if it's assuming it's an non-combustible wall, I believe they can be up next to it. I will add this, since I've repeated this several times, I'll add this to my list of things that I'm going to check on this afternoon, just to make sure I'm not misleading people. But I'm 99% sure that that's correct. The 600 kilowatt hour maximum rated energy, again, that's the default value. If one wants to have more than that in a fire area or outdoors in a container, that's possible, but they would need to do the large-scale fire testing.
Got it. And certainly on that 600 kilowatt hour limit, definitely folks writing in questions previously saying, is there any way, I guess this must be from a utility member, would a utility be able to be exempt or at least raise that 600 kilowatt hour limit? This starts to affect substation batteries.
Could you repeat that question, Jason?
I said, do you think that utilities could be exempt from or at least raise this 600 kilowatt hour limit? This would start to affect substation batteries.
So that the answer is I don't think that can happen right now. This is, we're way into the process at this point. I'm not opining on whether it's a good idea or a bad idea. I'm just saying that there's not a utility exemption
right
at this point. At least I don't believe there is, for that spacing requirement.
Got it. All right, moving on to some additional questions on the call. One person writes, based off of NFPA 855 or International Fire Code, is there a specific class fire for lithium-ion batteries?
A specific class fire?
That is what was asked.
Yeah, and I'm not sure. I'm not sure what the question is. Maybe if somebody else on the call thinks they've got a better understanding, I'm just not sure what the question is there.
No problem. I've written back to the questioner to ask for more clarification. I'll just move on in the meantime. Another question. Current NFPA standards require placing sensors in hard-to-reach areas, and some which don't make best sense given how the battery racks, ducting, etc. are placed in the container. Are there any provisions in the new standard regarding these issues, the issues about sensor placement?
Well, I'm assuming that these are like outgassing, fire, smoke sensors, temperature sensors, and part of that would be, I believe, captured in the 9540 certification. I believe I saw John Tacker on the line here a few minutes ago. I don't know if John is with UL, and so again, I think that the sensors would be required per 9540. Whatever sensors are required under 9540 would be what's required.
Right. I'm just tracing through and noticed that some other folks have chimed in with some comments in addition to questions. So one thing I'll just note reading off, one commenter says that this is back on the question of field evaluations, someone noting that field evaluations can and have been done on numerous installations of energy storage in accordance with UL 9540. These field evaluations are also in accordance with NFPA 790 and 791. Another person has noted or has really asked a question associated following up. They said, if over 600, it looks like they're saying volt, if over 600 volt, I thought the spacing is 4 feet between front of racks on each side. Is that correct, or am I missing something? I don't know if you have a response to that.
I don't. That doesn't ring a bell with me. I mean,
nope.
As I said, I'm not sure if the committee may have made a change here that we'll see when we get the report next week. Maybe that's the case, but my recollection was that.
Okay, next question. Are these standards different from existing standards that apply to UPS systems, or will this standard end up applying to UPS systems and things like data centers or any other battery backup systems?
Well, that's a really good question. It's a matter of some controversy in the committee. Remember, there's a 20 kilowatt hour threshold. Below 20 kilowatt hours, and the standards don't apply to it. So if the UPS is less than 20 kilowatt hours, then of course the answer is no. It's my understanding that there are UPS systems that can be 20 kilowatt hours or more, especially in telecom facilities, and that they would be subject to these provisions.
Got it. We are running into sort of the end of our time here, so I am going to see if I can get to one or two more. Sibel, can you make sure that I am with presenter controls? Great.
Sure.
So I think that there's another question associated with the 600 kilowatt hour limit. Specifically, this particular questioner, sorry, the conference controls are suddenly not working. Right, here we go. The question is, does the 600 kilowatt hours apply to the absolute max energy capacity of the batteries or to the nominal energy capacity of the batteries? This becomes important to the use of second life batteries.
Yeah, it's the maximum rated energy per fire area. So
thanks.
We're
going to go rapid fire through these because I want to get to as many as I can in the last couple minutes. Do you know what was the rationale for settling at 600 kilowatt hours? Why is any upper value specified?
I've never heard of really cogent explanation of why 600. The best I can come up with is that the fire marshals, the fire professionals are somewhat scared, and rightfully so. I don't mean it in any sort of demeaning sense. They're of energy storage. They want to be supportive, but there have been a couple of big fires, and I see the Hawaii fire referenced all the time in discussions. And the 600 kilowatt hours was something that someone, I think it was actually a New York fire department, first published 600 kilowatt hours, what I've heard, and everybody kind of just glommed onto it. We made a proposal to raise it to 1,000, and it was not accepted, and it was because it was a bare proposal. I think that if a person were to go in and make a rational explanation which would include testing data showing that it's essentially no more risky with 1,000 kilowatt hours than 600 kilowatt hours, they would probably accept that.
Right. Okay.
But we have to make a showing.
Last question that we have time for. This is the follow-up to that person who was asking about fire specifically. This person thinks that lithium-ion batteries could be classified as a Class B fire. Is there any information on this in NFPA or IFC?
Rather than belabor thing, I'll look that up and see and get back with you.
Great.
I'm not sure.
Okay. Unfortunately, we're at the end of the hour, so I think that's all we're going to have time for, and I want to thank Chuck for your presentation and taking this series of questions coming from all sorts of different places. It's hard to keep track of this stuff, and we appreciate you trying to field the many different questions you've received today. And for those of you on the call, again, just a reminder that registration for our 2018 Energy Storage Studio Conference is open in collaboration with the Electric Power Research Institute. Come join us to examine the steps necessary to successfully integrate storage projects. That's in Charlotte, North Carolina on October 16th and 17th, and you can find more information at energystorage.org/storage-studio. If you have any questions regarding any upcoming events or webinars or would like to submit an idea for a future ESA webinar, please email us. Hit us at education@energystorage.org. And otherwise, thank you again to Chuck, and thank you for joining us all in this important conversation. Enjoy the rest of your day, folks.